Hello? Can you hear me?
Yes, sir. Yes, sir.
Yes,
Can I
sir.
start?
Yes, sir. Yes, sir.
Okay, okay. I'm very sorry for this. Actually, is a I was not able to connect due to network problem. But now it's the problem is settled now, and just I will just elaborate on how to use SPSS software. Actually, SPSS software is a window-based software. These other softwares are also available, which is R software, Python software. I think Python software will be taken today. I think tomorrow lecture is scheduled. But Python, R software, these are the language-based software because it requires some language to communicate the software. But this SPSS software is a window-based software. So you just click and you will get answer here. Now SPSS stands for, this is a actually SPSS is a software specially made for this. SPSS stands for a statistical package for social sciences. Long form of SPSS is a statistical package for social sciences. And when you look at this software, so it looks like a Excel sheet. And this Excel sheet, when you look at this windows, so it looks like a matrix. In a matrix, em rows and n columns are there. So here rows represents the cases, and column represents the variables here. That yesterday in my lecture I told you, in a data analysis we require only two things, which is a number of individual and characteristics of that individual. So here this number of individuals represents rows and their characteristics represents columns here, which is if you've seen this software window, so there is a variable var is written here there. So this is in a column, you can put it there variables, and in a rows number of individuals. So actually this software has two windows. One is a data window which is open now, and this is a variable window. The second one is a variable. This is a variable window. See, when you actually role of software begins after collection of data. After collecting the data through survey, questionnaire, and then you try to feed your data in a SPSS software. So first you open the variable view window, and in variable view window there are some options are given. See, in a first row, this is if you see this, name is given. Name means what? This is a variable name, and it has some rule to write there. What are these rules? You don't begin with this variable name by any special characters like and, hash, one numeric also. If you take a numerical here, 1, so it will not take. You will see this is. So the one message will be reflected here because variable name contains an illegal first character. So always you begin your variable name with characters. Actually, the rule of this naming variable name is this, because when you ask questions in a questionnaire, so your question would be long question. Like suppose what is the gender of the respondent? So this is a long question. So you concise this question up to 8 characters or 10 characters. This is, so here we can write this is a gender like this. In a second, you just understand what actually these menus are given. This is a variable name I have written here, and gender is a nominal variable, which is a categorical variable. Generally, we cannot apply statistics on a qualitative data. This qualitative data convert into quantitative data by coding method or scoring method. So that's why here when you click over here, See, you will see here this dialog box will open. So here this by default this numeric option is selected here by default numeric. So other options are there also because your data may be in some other format. So if your data is in other format, so this possible formats are given here. If your data is in comma, dot, scientific notation, date, dollar, custom currencies. String means if you are feeding data in a string operation. String means in a characters like a name, like a gender, like a Ramesh, Manish, like this. This is a for this string correction string option you can apply. But here by default this numeric option is selected. Why this numeric is selected here? Because we cannot apply statistics on a qualitative data. This qualitative data convert into quantitative by coding method. So this numeric you keep as it is. This is a so you numeric keep as it is. This is a width. Width is a this is a variable width. Means this is a gender. Gender has how many characters are there? GEN. These are 6 characters are there. So we have set as a 8 width of this. Means gender is 6 character, means width of this name of the variable is a 6. This is so I have you can increase here also. This can be increased, this width here. This you can increase decrease this width as per your requirement. This now decimal is a decimal. If your data in a fraction like 1.25 1.30 like this, so in this if your data has a 2 decimal point like 1.20, suppose after this 1 point there is a 2 digit, so you set as, if there is a 4 digit, then you set as a 4 digit after fraction. So decimal, if there is a no any decimal, so you can set as a 0 here. So here now here this label is given. The label see most of the times what happen, we have given this variable name in a very in short, but sometimes we don't know for which question we have given this short variable name. So here you can put it here complete question here. What is a gender of, for your understanding, this is what is gender of a respondent. Complete question you can write here for your understanding, because what because this variable name we have concise up to some 8 characters and 10 characters, so it is necessary. So see, actually this variable name will not be reflected in your output, but for your understanding you can put there. Now here this gender, now gender is a qualitative variable. If variable is a qualitative, then you can use this option, this values option. Now gender has a 2 levels or 3 levels. Suppose gender has a male, female, and transgender is there. So you can put here, this is a 1, you can label here, this is a 1, then give tab and you put it. Now I'm coding data. This is a male coded as a 1, then female coded as a, see this female coded as a 2, and you just say okay, because this is a qualitative data. If there is a continuous data, then there is a no requirement for this. See, missing option, actually in a software given facility, if there is a cell is missing, so it gives there shows this values are missing. So you don't do anything here because it will not any affect. See, this column is this is a width of column of data view window. This is a data view window. If you want to increase this width of column, so we can increase this width. See, here is a, this is 9, you can increase here 10, 12, 13 like this. So here you will see here in a data window, this is a gender columns width is a increase somewhat. This is So, but 8 is sufficient. So you can set as a 8. See, this is a alignment. Alignment is just for a decoration. If you are superstitious, then you can put some. Sometimes somebody wants to keep their number in left side of cell, right side or center. So, but it will not affect on your result. You can put it as per your thinking. This is so. This now in yesterday I have taken this a scale of measurements. The scale of measurements is very important because uh, I have taken this 1.5 year half hour lecture on this how to choose appropriate test for appropriate data, because the scale of measurements are playing very role in choosing the important statistical test for your data. See, under yesterday we have seen this level of measurements are ratio scale, interval scale, ordinal scale, and nominal scale. And this, actually in a SPSS software, this ratio scale and interval scale actually both are continuous scale. So these are given in a under scale option here, and ordinal and nominal are categorical variable. Now here gender is a nominal, because definition of nominal variable is what? A variable having categories without natural order. So we are not finding here any natural order in a male and female, because we don't discriminate. Male is higher and other female is inferior, because there is a no hierarchy in this. So this is a nominal variable. So you just click on a nominal variable, because why? This scale of measurements are playing very important role to choose appropriate test for a appropriate data. This is now here. Then if your variable is age, for example, now age is given in a number, means it's a continuous variable. So there is no need to write anything here in a columns, because type numeric, because age is a numeric. Then here only here you can write age of the respondent. This is, and here now this option is a not required here. This option is not required here. Why? Because this variable is a continuous variable. This variable is not qualitative. This values option is only applicable when you have qualitative variable or categorical variable. This is like educational qualification, SSC, HSC, UG, PG, your religion, Hindu, Muslim, Sikh, Christian, like this. If such kinds of variable is there, only in this case you use this values option. Otherwise, you leave it. Because age is a continuous variable, so there is no need to write, because there is no level. When you collapse this age variable into intervals, then only in case that you can use the, suppose if I'm converted that variable age as 0 to 10, 10 to 20, 20 to 30, 30 to 40, like this. Only in this case you can then use this variable, because continuous variable we have converted into categorical variable. This, only in this case we can put it. Now see, if your questionnaire contains 20, 25, 50 questions, so if your each and every questions will be treated as a variable here. This is categorical. Now when you look at the any survey questionnaire, so you will find two types of variable: categorical variable and continuous variable. Continuous variable like age, blood pressure, this systolic blood pressure, then this variable, height, weight, these are the continuous variable. And categorical variable, this ordinal or nominal variable, these are categorical variable. And only these two types of variable you will find in any questionnaire. This is, so you just put it your all the questions in a variable window, 40, 45 questions, whatever you have collected in your questionnaire. So you all variable, you put it in a variable window, and after putting variable window, then you open data window. Now see, whatever I put it in a variable window, this all variable is reflecting over here in a data window. It's a gender, age, this. Now you just pick up the questionnaire. See, I told you this very actually this sheets looks like a matrix. Matrix, rectangular matrix, M by N matrix. This is a in a matrix, this uh, rows, M rows and N columns are there. M rows, M by N means M rows and N columns. So here this rows represents the your cases, means number of individuals. Now you all are belongs to the veterinary, so you are here individual maybe animals. So here number of individuals means animals. So you can put 1, 2, 3, 4, 5, 6 like this. So these all rows represents the cases and column represents the variable. Now characteristics of that individual means whether this if you have taken animal as a number of individual, whether this is a buffalo or cow, a gear cow or any another a pet, this dog. So these are the characteristics of that animal. So you can put it here in a window. Now now here we have coded already. Now gender male female we have coded here. If this it is first case is belongs to male, so you put it 1 year like this. If it is belongs to female, you put it a male like this 1 2 1 2 1 2 1 2 like this 2 whatever your data. This is 1, and here age is, suppose this is a 20-year age, 30 age, 23, 34, 56 like this. You can, in this way, you can put it your data in a Spss software in a data window, and then save your file. Here, save option is here. So here, see, I'm not focusing on all the menus because it will take more time. So without any spending more time, so I would like to show you how to perform parametric test and non-parametric test in a SPSS software or this chi-square test, what I have taken yesterday. So see, actually I have because I don't have data related to veterinary science, but I have one already. I have made one file that I would like to show you. So and how to analyze data, then I will show you, because already this data is a feeded. Yes, let me share this file. See, this is a file. See, this is a variable view window. Variable view window. Here I have actually this data is not related to your veterinary science, but this data is related to social science, socio-demographic data. But you can understand this. See, in a data, this is whatever these are 11 variables are there. This age, gender, qualification, religion, marital status, income, type of family, how many family members in a family, then their blood pressure, whether it is smoking or not. So these kinds of variable I have collected. Just I will just try to show you how to perform this test, different test in a SPSS software. See, SPSS it's a very easy software. This is window-based software. For example, if your research question is like this, see, yesterday also, if you've seen my PPT, so first research question is this: is there any association between pet lover and marital status? Pet lover and marital status. So actually, this data I don't have, but we can take another example. Is there any uh, association between educational qualification and marital status? Because educational qualification and marital both are categorical variable. So here chi-square test is appropriate here, because both are measured on a chi-square, both are measured on a nominal, both are categorical variable. Actually, educational qualification is an ordinal variable, but we can use this variable for a chi-square test. This is see here in a software. Uh, Actually, this is where is this? Actually, this is not uh, showing due to this. How to remove this? You know? Do you know anybody? Is actually yes. Okay. This is analyze in a descriptive window. This cross tabulation option is given. See, actually in a descriptive. See, when you generally for a data analysis, we go step by step. Means see whatever variable you are looking at in a SPSS data window. These are the variables. See, when you are doing first you do univariate analysis. See, when you are analyzing age variable, so here age variable is a continuous type. So here you will get information about the what is the mean of this population, mean, mode, median, standard deviation, standard error. This information you will get. But when you have a qualitative type variable like a gender, because gender has a male and female, these levels are. So you will get information, because this is information about how many males, how many females. If your data contains 200 sample size, then how many males are in that population, or how many females are there. So only that information you will get for qualitative variable. But when you have continuous variables, so you will get mean, mode, median, standard deviation. This because here gender we have coded male coded as a 1, female coded as a 2. It's look a numeric, but these are only identifier of that level only, nothing more than this. If you have calculated mean of this, so it is meaningless, because male we have coded as a 1, female coded as a 2. These are only identifier of that variable, nothing more than this. If you have calculated mean this, you will find it is not a useful. Now here, if your hypothesis like this, is there any association between educational qualification and marital status? So here, which test is appropriate here? So here, chi-square test is appropriate. So you just click on a chi-square. See, this dialog box will open here. Now here, this left-hand side, all variables will be reflected. Whatever you have put it in a variable window, this all variable will be reflected here. See, age, gender, qualification, that variable we have put it in a variable window. Now you just pick up this variable. Suppose if you want to see, is there any association between educational qualification and marital status. So this educational qualification, and we pick up marital status here, column can fit anywhere. Column, it is up to you. This is now here in a statistics. When you click on a statistics, so this option is here. So this chi-square option is given here, and correlation is option also here. If you have two variable measured on a continuous scale, then you click on a correlation option. This is, but here both variable are measured on categorical data, so you click on a chi-square option. Now yesterday also I told you this chi-square test, it gives only test of significance. It will tell you only inference about whether this association or not between educational qualification and marital status. It will not give how much is the strength in their relationship, how much is strength. If you want to see how much is strength in their relationship, then you use this phi and Kramer's-V statistics, because phi statistics is given for when your 2 by 2 contingency table is given. So it is a phi coefficient you use for checking how much strength in their association. And if you have m by n table, then you use Kramer's-V. This everything I have given in a slide in a PPT. Actually, this PPT I have shared with Dr. Sajid Ali. So you can take this PPT from Sajid Ali. So everything is written in this PPT. So in chi-square, so you just click over here, continue, and if you want so expected frequency, because expected frequency should not be less than 5 in a cell. If you want a row percentage, column percentage, like this, so you can click over here and continue, and just click OK. See, now see this output. Can you see this table? See, this automatically this table you will get this. This educational qualification has a 5 levels: SSC, HSC, UG, PG, doctorate, married, unmarried, widow. So this is a M by N contingency table. Actually, these are 5 rows and 3 columns are 5 by 4 tables is given here. Can you see this table output? Can you give me any? Can you see this output?
Yes, sir. It's visible.
Yes, visible, na?
Yeah,
Yes.
yeah.
So,
Yes.
so automatically, whatever data you have, 1000 sample size, 2000 sample size, so automatically it will summarize in a table with a percentage and expected count and all this. Now you look at this chi-square. See, now chi-square test table is given here. In the chi-square test, this chi-square value is 11.902. and degrees of freedom is 8, because your table is a m by n table. So chi-square distribution with m minus 1 into n minus 1 degrees of freedom. So here m is a 5. So 5 minus 1 is a 4 into there are 3 level has a married, widow, married, unmarried, and widow. So there 3 minus 1. So 4 into 2 is 8 degrees of freedom. This is m minus 1 into n minus 1. And this is a p-value. This is actually in statistics there are 2 approaches: p-value approach and critical value approach. This is if you calculated chi-square test manually, so this chi-square table is given in at the end of any statistical book, which is called as this biometrica table, and this chi-square table is given. These values are critical values are given in that table, but software gives p-value approach. This is p-value. So here p-value is a getting 0.155. See, universal testing criteria is this, and this is applicable for everywhere. This is if p-value is less than 0.05. If you are testing hypothesis for 5% level of significance, then if p-value is less than 0.05, then your null hypothesis may be rejected. Otherwise, accepted it. See, your null hypothesis here, see, what is your statement? There is an association between educational qualification and marital status. So when you're writing the null hypothesis, you write in a negation form. This is, there is a no association between educational qualification and marital status. So similarly, you can you can put it here. There is no association between pet lovers and marital status. Your domain knowledge you can use here for analysis. This similar type. So here p-value is a now here it's a greater than 0.05. If you are testing 5% level, so greater than 0.05, it indicates that accepting the null hypothesis. So your inference would be this. So there is a no association between educational qualification and marital status. This is, there is no association between this. See, for finding the strength of association, see here. Now this table is this symmetry measures table is given here. Now there is a Cramer's V and phi coefficient, both are given here. So phi coefficient is given for 2 by 2, but you look at the Cramer's V, because why? This table is a m by n table. So you look at the Cramer's V, and it's a weak association is showing, because this Cramer's V value is lies between 0 and 1. Cramer's V value is lies between 0 and 1. So if value is nearest to 0, there is a weak association. If value is a very nearest to 1, then there is a association. There is a strength in their association that you can say. This is a chi-square, and in this way you can see. I'm again I am sharing this. See, your hypothesis. If your research question like this, is there any relationship between blood pressure and age? Blood pressure and age. Now see here, blood pressure and age, both variable now here measured on a continuous scale. Age is a continuous and blood pressure is continuous, and that you know, age is directly proportional to the blood pressure. If age is increasing, blood pressure is increasing. So if you want to check this, whether there is a correlation and how much strength is there, so you use here Pearson product correlation. Pearson product correlation. So again you go to the analyze, and here is a correlation option is given. Here, correlation option. You click on a bivariate correlation. See, here is a given Pearson, Kendall-Stauby, Spearman. So yesterday in my slide I have written when to use Pearson product correlation, when to use Spearman correlation, when use a Kendall-Stauby. See, Kendall-Stauby we use when you have both the variable measured on ordinal scale. Ordinal scale means ordinal means a variable having categories with natural order is called as a ordinal variable. So this when you have both variable measured on ordinal variable, you use Kendall-Stauby. Kendall-Stauby is the appropriate test is there. Now here is a Pearson, both variable measured on a continuous scale. So here Pearson product moment correlation is a appropriate test. But if your data set in a age or in a this blood pressure, if your data contains more outliers, then this Pearson product correlation moment values, it gives very poor result. So in this case, you don't use this. You use Spearman rank correlation. If there is a more outlier present in your data set, then you go for the because while ranking the data, your this outlier effects will be eliminated automatically. This is so here Pearson product correlation. So here you just take age here over here and blood pressure. This both continuous variable you take here, and you just click over here. You will get output. This output is here. See, now here this correlation matrix is given here. See, this blood pressure is 0.696 and 0.696. This is a blood pressure. Now it is a positive, so it indicates that both are increasing simultaneously. This is, if this blood pressure and their correlation R value is a, and this is a good strength in that, because 0.70 values is a very much nearest to 1. So good strength is there. In this way you can use this correlation. Now these are the correlational. See, I in my slide also I have written this. All the statistical measure tests are divided into two parts. One is the exploring the relationship among the variable and exploring the difference between the variable. Difference between the variable. So here only the major statistical tests are divided into this two statistical methods. See, here is a, see, while doing a bivariate analysis, exploring the relationship among the variables. Now, exploring the relationship among the variable means, is there any association between gender and qualification, gender and religion, gender and marital status, or income and educational qualification, then income and family members. This, it is depends upon your research question. This is because generally research process, any research process begins with a your objective and research question, and then accordingly whatever research question asks, then we collect the information about this research question. So we include only those variables which are related to your research question. See, now this is a bivariate analysis, means exploring the relationship between among the variables. Now second one is exploring the difference between the variables. Now explore the difference between variable means, if gender, now gender has a two level, male and female. Is there any difference between male and female? If educational qualification variable is there any significant difference between SSC, HSC, UG, PG, like this? So if you have such kinds of hypothesis, then your technique will be changed here. Now, if your research hypothesis is like this, is there any significance difference between gender? Is there any significance difference between male or female of blood pressure, male and female of blood pressure? So your research question is this. Now what information you require to fulfill this research question? Now you require one variable, which is a categorical variable, which has only two levels. This is, now here is a gender has a two level only. See here, if you have included transgender here, because gender has a two level, male and female. When you have only two level, male and female, you use independent sample t-test. If I added one more variable there, transgender, then we cannot use independent sample t-test. Then which test is appropriate there? There is Anova is appropriate, one-way Anova. Because one-way Anova we use when there is a more than two levels are there. One-way Anova we use. So in this situation, use. Now how to perform? So here is this option is given. See, compare means option. These all are the parametric tests. But these tests are depends upon some assumptions. Assumptions what? Data are independently distributed, normally distributed, and it should have constant variance. So these assumptions should satisfy. If these assumptions are satisfying, then you use this parametric test. If this assumption is not satisfying, this, now then here this non-parametric test is given. See, one sample, independent sample, related sample. This, see here, this chi-square is a non-parametric test. Then one sample. So these alternative non-parametric tests are given. If the data is not following normal distribution, then you go for the this test, non-parametric test. So here, see how to use this independent. Now, if your research hypothesis is like this, is there any significance difference males and females blood pressure? Now here, which test is appropriate? Here independent sample t-test is appropriate. Now here, see, you put it here. See, you put it here. This gender, blood pressure in a test variable. This blood pressure in a. नंतर फोन करा मी लेक्चर देतो. Blood pressure is a test variable, and this is gender grouping variable. See, define this group 1. Now here male we have coded as a 1, so you put it as a 1 here, and female as coded as a 2, so you put it as a 2 here. So continue this, continue, and just okay, you will get result. This I will share this. See, this is output of independent sample t-test. This is, so this total number of sample size, and this is a t-test is a see, look at here. Actually this EF test is a given for a whether your variance are constant or not. So generally null hypothesis we put it as a all variances are constant, and alternative hypothesis variance is not constant. So here p value is a for F test is a significant value is a 0.615. So this assumption is a valid constant variance assumption. Then this 98 degrees of freedom, this n1 plus n2 minus 2 degrees of freedom are there. So n1 is a 57 and n2 is a 43. Males are 57, males are there, and females are 43. And when you take minus 2, so actually is 100 n1 plus n2 and minus 2, which is you will get degrees of freedom is 98, and their p value is here. This p value. Now here p value is a, now here your null hypothesis would be there is a no significance difference between male and female's blood pressure. Male and female's blood pressure. Now as per p value, when you look at the p value, the p value indicating this p value is greater than 0.05. It indicates that there is no significance difference between male's blood pressure and female's blood pressure. This is. So here, in this way, you can take make conclusion. Now, see one more example. Now here, compare means. Suppose your research question is like this: is there any significance difference between marital status and blood pressure? Marital status. Now here we cannot. Marital status has a, see, marital status has a 3 levels. 3 levels: married, unmarried, and widow. Now when you are only married and unmarried, you use independent sample t-test. When you are including other married, unmarried, and their widow, then independent sample t-test is not appropriate. There is a one-way Anova is appropriate here. You just click on a one-way Anova here, and in a one-way Anova, see, now here which information you require. So we require one categorical variable which has a more than 2 level for one-way Anova, and one continuous variable which is a blood pressure. So dependent variable is a blood pressure here. So you take it in a dependent list box, and this categorical variable marital status you take in a factor. Always there is a, this position is fixed here in dialog box. In a dependent list box, always you drag only those variable which are continuous type, and in a factor you drag only those variable which is categorical. But categorical variable with more than 2 category. If there is a 2 category only, like a male, female, only married and married, then you cannot use this one-way Anova. One-way Anova is not appropriate here. One-way Anova is appropriate when we have this categorical variables has a more than 2 levels. This is that you keep in your mind. This, and just you click OK, you will get a result. This is, see, this is a one-way Anova table. This is between groups, within groups. And here is this is a sum of square degrees of freedom, because 3 levels are there: married, unmarried, and widow. So this how many levels? -1. So that's why 3 levels are there. So 2 degrees of freedom is there, and significant value is a 0.899. So it is a greater than 0.05. So it indicates that there is no significance difference between level of married people's blood pressure. This is what we. And now, if here is another variable, 2 variables are involved, then you use 2 variables. If 2 categorical variables are there, this is a 2-way ANOVA. This is. So in this way, if these assumptions are not valid,